In this video we are going to solve the next games in Cheat Engine. I am not going to explain the tools again. In this game we have 5 bullets. After using the 5 bullets, the target automatically increases its health while we reload our weapon. So we need to kill the target before our reload. For this you can use various methods. I will show you the simple one. First, we don't know the target's health, so I set the scan type to unknown initial value. We don't know the data type, so I simply set it to 4 bytes. If it fails, we will try another data type. Mostly games use health data types like 4 bytes or float. Try to damage the target. Now the target's health decreased, so we need to change the scan type to decreased value. Or simply use the shortcut you set by following our video. I only use shortcuts here. I already showed the process in our part 1, so I am not going to explain it in depth. Here we got the value. Let's change it to 1. See, the game is completed. Move on to the next game. In this game, these 2 enemies have more health than we do and deal more damage to us than we deal to them. In this scenario, always first make sure the enemies also access the same instructions that affect health as we do, that way we can separate them from us and make scripts. So let's find that out. Let's find our health value. We got our health value. Let's see what writes to this address. We got our code. Now let's see what addresses this code accesses. See, we got our 3 players' health values. Now find the commonalities between those. You already know the process, so I am not going to explain again. If you don't understand, then watch our part 1 video to understand better. In our instruction we have the racks register, so double click on it. At offset 60 we have our players' current health values. At offset 70 we have the commonalities. Now let's do code injection. You can come up with your own coding skills and methods. I create a new label called kill which I am going to use for a one-hit kill. Here we need to compare our commonalities at offset 70. If it equals 1, which is enemies, then it will go to our new kill function and take the one-hit kill instruction. If you didn't understand these instructions, then watch our part 1 video. Now let's create our kill function. Here I will move the value 1 to the current health address. In our code, if the value is not equal to 1 then it goes to the original code block to execute the original code. Here we don't need this, so let's comment it out. Below we have 2 more instructions. If you didn't understand, then don't worry. We will cover everything later in detail. But for now just remember, if we have a return instruction in our original code, that means the function has to return a value. So never comment out these instructions. If you want, you need to add these instructions in your own methods to make the code flow correctly. Otherwise the game may crash or its behavior may be disturbed. So in our new mem we didn't need to include these two lines because after the comparison it will go to the original code block. This is because we didn't use an unconditional jump and the original code block is under the new mem block. But we didn't use a return in our kill method, so we need to include it. Otherwise you can directly jump to the original block if you don't comment out those lines. Let's add this script to the address list and run it. See, our game is completed. But if you observe, when we use our script the game shows some integrity check errors. We will discuss this briefly later. We are in our final game. This game has a lot of ways to solve it, like collision with enemies, teleport hack, fly hack, etc. I will show you one method. Let's find the player details. For this I need to find his coordinates. Now we don't know his coordinates and coordinates are mostly stored as float data types. So I will set the scan to unknown initial value and the data type to float. Now let's move to the right side to increase the value. Here I am using shortcuts. Now let's search for unchanged values. See, many values are not changing. When I just click in the game, some values change and a few do not. So let's try those. I picked the first one because I already know his position is this. Now let's see what writes to this address. We got the instruction. To see the player details, take the rack's register address and go to memory view and click on dissect structure. Now paste the address here. Click on Define New Structure. Here we have all details of the player. Let's observe the values. See, these two values are our x and y coordinates. Let's add these values to our address list. Now let's find our collision value. Let's observe which values are changing. Some values around here are changing. Let's check again. Did you see that it changes to 1 when we collide with the enemies? Let's check if it is the value we are looking for. Now let's see what writes to this address. When we collide with enemies, it moves one into the register. Now set a breakpoint and understand the flow. Now try to die. Now let's see what functions call this instruction. Go to View, click on Stack Trace. This is our current instruction. Understand this code. See, there is a test instruction. After this we have a conditional jump. If the value is equal, then it jumps to this location. Otherwise it will continue the following instructions, take effect, and make our player die. So let's change this conditional jump to an unconditional jump, so that it always jumps to the location no matter what. I forgot to stop debugging. Click on Run and it will be normal again. Now try to die again. See, nothing happens to us. Now let's make these all green. I am bad at this game. But we have our coordinates, so we can tweak those to teleport. Let's change our Y value to teleport. Now let's change my X value as well. See, our game is completed. Here also we have the integrity check error. But we will learn why these errors occur and how to solve them in our future videos. Always try to solve the problems in different ways. Then only you can improve your skills. See you next time.